Hello, everyone. You are welcome to today's lesson. And as you can see on your screens, today we are going to look at the solution to the class test on rational functions and partial fraction. Okay, so the solution comes with indirectly the marking scheme just to guide you to mark, okay, your work. So quickly, without wasting time, let me walk you through the solution, and at each step, okay, you will see the marks allotted. Okay, so now let's look at the first question. So this was the first question. Write the partial fraction identities of the following. Now remember, I've told you, okay, anytime you are writing any exams, you are going to provide solution to any question. Immediately you read the question, never forget to underline the salient part, if any. So we are going to strictly go by that. So write the partial fraction identity. So you underline identities. Very critical of the following. So it means here you don't have to go beyond the identities. Okay, you don't have to find the letters that you introduce in the identities. You just end up with the identities. So those of you who went beyond that, obviously I realize that you didn't pay attention to detail. You didn't plan protecting our marks. So please take notes. Make sure you don't repeat such mistakes again. All right, so now what do we look at? We come to, so the first thing after underlining the salient part in the question, the first thing that you write is solution. There is a major question number, you write it, and that is question number 1. Okay, and we are looking at question number 1A, so A, where A is also indicated here, the sub-question number. Then you extract what you are given to write its identity. So there's the rational function that you are given to write its identity, and immediately you extract that B half. Take note. So at this point, what do? We know we move straight away to the factors in the denominator. Remember, the very basic question you need to ask yourself is the rational function that or rational fraction that you have there. Okay, is it proper or improper? So obviously degree of the numerator is 2. That of the denominator will be 4, because the degree of this factor is 2. The degree of this factor is 2. So if you add, you are going to get 4. So making this a proper rational function. In that case, okay, we know that we can move straight away to the denominator. And the denominator, remember the trick. Okay, check each of the factors. If any of them is factorable, then okay, you factorize before you can write the identity. It means you cannot write the identity straight away. So let's check. Okay, with this one, we are going to perform the check to determine whether what we have here is factorable. Remember, if it's factorable, the value of b squared minus 4ac should give you a perfect square. So that's your b here is what? Minus 5. So minus 5 squared. We are performing the test as our rough work before we go and stress ourselves. Minus 4ac, 4. What is your a? Your a is the coefficient of x, which is minus 1 here. Okay, and what is your c? C is the constant here, which is 2. Please take note. So at this point, we are going to get 25, okay, plus what? 8, okay, which will obviously not give you a perfect square. Okay, because we are going to get 33, which is not a perfect square. So it means this is not factorable. Okay, so we can, now let's come to this. You perform the same test. And if you perform the same test, you realize that this is not what is equally not factorable. So it means straight away you can draw your conclusion by writing the identity. So therefore, what I was given to write its identity will be equal to, because there's a quadratic factor and it's not factorable, its numerator will be linear and it will be of the form as plus b. The second factor is also quadratic and it's not factorable, so its numerator will be linear, just as you have there. So instead of bs plus what? C, because you have used a, so instead of as plus b, you have used a, you have used b, so you go and use different letters. Okay, cs plus d, you know this, okay, based on our previous lesson. And here, 2 non-factorable quadratic factors indirectly informed us that we are going to get 2 fractions in parts, and that's exactly what you have here. So this explains the solution to question 1a. Quickly, that's of the b. So 1b, and remember, if you are moving from question 1a to 1b, you leave a line. Then you come and extract Okay, again, this is what and you remember this was a question that was given to you as a class exercise. So this is a known question. Okay, so I won't talk much about that. The solution is on my YouTube platform. You can go and watch it. Okay. However, I will do my possible best to explain for you to get it here as well, though I will rush you through. So in this case, remember, you ask yourself, you have a quadratic factor here in the denominator. Obviously, this is a proper. Okay, a proper rational function. Degree of numerator is 1. That of the denominator will be 4 because it will be this one multiplying itself twice. The degree of this one will be 2. The other one that it will multiply will also be, so it will be 4. So 1 over 4 proper. At this point, what do we do? Okay, because this quadratic, okay, factor here, repeated factor, is factorable, you cannot straight away go and write the identity. Okay, so if it wasn't factorable, then we can write the identity. So it means I have to come and write equal to. Okay, and equal to, I come and factorize my quadratic factor in the denominator, which is repeated. And you know, difference of 2 squares, which if you factorize, you get this. Don't forget this, the whole of this one squared now. So it will be this one squared, okay, times this one squared. So now you have 2 linear factors, okay, repeated. Okay, so at this point, you can write the identity. You know that this factor will give you 2 fractions. This factor will equally give you 2 fractions. So you are going to get 4 fractions in your identity. So therefore, whatever that you were asked to write it, identity will be identical to, and take note, if you use equal to here, it will be, okay, A0, I've told you. Okay, it's an identity. Okay, A0 here, if you use the equal to instead of the identity. So that will be the penalty that will come from with it. So now this, you know, will be repeated. So it's repeated. The first one, because it's linear repeated, it will have a numerator to be a constant. So a over s plus 4. The second one will be b over s plus 4 squared. You come and do same for this one. Okay, c over x minus 4 plus d over x minus 4 squared. So that will be it for the solution to that of the b. I guess my point is well made there too. Okay, now we come to the c. Okay, c, this is what we are given. So you extract b half. Okay, let's see whether we can write the identity straight away or we have to further factorize any of the factors. Okay, first question, proper or improper? So this is proper. Degree of the numerator is 1. That of the denominator will be 3 because the degree of this one, you know, it will be this one multiplying itself again. That's the meaning of this. So it will be 3 linear factors, though one of them will be repeated. So what do we get? We get 3 degree 3 here. So 1 over 3 proper. Once it's proper, we come to the denominator factors. Okay, so linear factor, which is not factorable. Linear repeated, so it's not factorable. So I can write the identity straight away. So that's why you have the conclusion drawn there. And it's identical to this linear. Okay, so and it's not repeated. So it will be a over, it will give us only 1 fraction. A over s plus 2. This is linear and repeated, and the power here will tell us that it will give us 2 fractions. Okay, so it will be plus b over s minus 3 plus c over s minus 3 squared, you know, from our previous lesson. Okay, so easy as well, and I guess my point is well made. We come to that of the d. Okay, so the d, okay, we have degree of the numerator is 2. Degree of the denominator, this is 2, this is 1, so it will be 3, so again proper. Okay, so once it's proper, we go to the factors in the denominator. So this is a quadratic factor. Let's check whether it's factorable. Okay, so if you perform your b squared minus 4ac, you realize that it is what? Factorable, because you get a perfect square. Or you multiply this and this, which will give you negative 2. Do you have factor pair of negative 2, which when you multiply, you get negative 2. When you add, you get negative 1. Yes. So it means this is factorable. This is linear and obviously not factorable. So your concentration should be on this one. I remember I told you, okay, because we cannot write the identity straight away, okay, because of this factor, which is factorable, you come and write equal to, keep your numerator, your denominator, you come and factorize this. But remember I told you in our previous lesson, okay, we have to take whatever that we want to factorize as a rough way. So the factorization is done here, and I guess you can, okay, relate. So the factor pair will be minus 2 plus 1. So you use that one and you use the factorization by grouping. Then you import your factorized result here. So you can see that I've imported the factorized result. So this, the whole of this is replacing this by times x minus 1. Okay, so at this point, if this happens to be your rough work, don't forget to cancel it. Okay, just like this one, if it happen to be your rough work, don't forget to cancel it. But cancel it in such a way that it will still be readable. And you can see that there is a method mark for that. So this rough work is vital, so you get a method mark for it. Okay, so at this point, okay, some of you will write, take this as, okay, a linear, another linear. Okay, but take note, most of you were caught in the web. You can see that this time around, these two linear factors that you have here are repeated factors. I mean, are the same factors. So this is the same as this. They are the same. So in that way, you are dealing with x minus 1 squared. So failure to write it this way will spell doom. Okay, you are lost. So at this point, this is linear, okay, not repeated. Now, this simplifies to linear repeated. So anytime you factorize and you see a linear factor repeated, don't split them. Don't treat them separately. Because you know that you don't write x, okay, times s as our final answer. It will be s squared. So write it as such and use that one to determine how you write your partial fraction. I guess my point is well made here. If it is not well made and you watch the video, pass your comment. Okay, I will address your concerns there. So now, what do we have here? Linear, which is not repeated, linear repeated. So this will give you one fraction. This one, the power here is 2 repeated. So it will give you 2 fractions. So in all, you get 3. So I can now draw my conclusion because these 2 linear factors, none of them is factorable. So I can write the identity at this point. So therefore, whatever I was asked to write its identity is identical to this one will give me a over 2s plus 1. This one gives me b over x minus 1. And the next one for this one will be c over x minus 1 squared. Okay, so if you don't get the concept right, okay, go and watch my lesson on YouTube, okay, on writing the partial fraction identity when you have repeated factors. Okay, so now at this point, we are done with that of what? The D. Now let's go and look at what? The E. Okay, which most of you, okay, you were caught in the web. Okay, at this point, you know that this is proper because degree of numerator is 1. That of the denominator is what? Is 3, so proper. Okay, then what do we do? Come to the denominator, check whether the denominator expression that you have there is factorable. And most of you didn't see this to be factorable. It is. You are dealing with difference of 2 cubes. So you should know the factorization of difference of 2 squares. Okay, and now you should know the factorization of difference of 2 cubes, then sum of 2 cubes. Unfortunately, we don't have factorization of sum of 2 squares, but we have factorization of sum of 2 cubes, then difference of 2 cubes. So in terms of cubes, we have the sum factorization and the difference factorization. But for the squares, we have only the difference factorization, not the sum. Okay, so anytime you have an expression a cubed minus b cubed, it factorizes into a minus b. You should know this just as you know how to factorize a squared minus b squared. That's the difference of 2 squares. Once you know how to factorize this, you should know how to do. You know that this will give you a plus b, a minus b. You should equally know this off head. So this will give you a minus b as a factor. Your second factor will give you a squared plus what? AB plus B squared. So if your sign here is negative, your first factor that you have there, it will be the difference between the 2 terms that you are, quantity that you are finding a difference in terms of the cube. So A, then the B. Okay, then the second factor, okay, all the terms will be always the second factor. The first term will be negative, positive. The last term will be positive, and it will be a square. So the first term is the square of this one. The last term is the square of a second quantity that you are cubing. Okay, however, the middle term, the sign there will depend on this. If this sign here is negative, the sign here will be positive. Take note. Okay, I'll take you through, though we are not doing the sum of 2 cubes, I'll take you through that of the sum of 2 cubes as well. So this will be the factorized form of any expression of this form. In the same way, so if you have a cube plus b cube, this factorizes into a plus b as one factor into a squared. Okay, if this is plus, then your second term will be minus. So it will be minus ab. Take note, it's not minus 2ab. Okay, then plus what? B squared. So this will be, and if you like expanders, you come and get this and simplify. Expanders, you come and get this. So you should know the factorization of difference of two squares, okay, sum of two squares, then difference of, sum of two cubes, then difference of two cubes. You should know the identity. So this is an identity. This is also an identity you need to know offhand. So if I'm looking at this, obviously I can see that what I have here, look at it critically, what you have here is the same as s cubed minus 1 cube. So difference of 2 cubes. So in this case, your a is equal to x, your b is equal to what? Is equal to 1. So that gives you a x minus, okay, 1, because a minus b into a squared. A is x, so it will be s squared, okay, plus ab, so plus, okay, a is what? Remember, a is x, b is 1. So ab is s times 1, that will give you x. Then plus b squared, b is 1, so 1 squared is 1. So that gives us the factorization. So if you are matured, you can factorize the denominator here to this. And because this is factorable, you couldn't write the identity, so you have to go through the factorization. So it's equal to this. Okay, so here you should know this off head. The factorization, it doesn't need any more step, just one step. If you are mature, you should be able to factorize. Just as if I gave you difference of two squares, one step, you should be able to factorize. So rough work is not necessary. So at this point, you have a linear, non-factorable, a quadratic, which is also non-factorable. Okay, so now what do we have? You can write the identity straight away. So therefore, this linear will give you one fraction. So this will be identical to the fraction by this linear, which is this, plus the fraction by this quadratic non-factorable, which is this. So take note. Again, if there is anything there that you don't really or you couldn't relate, when you watch the video, pass your comments and I will, okay, address your concerns there. Okay, so that will be it for the solution to this one. So the whole of the question 1, 13 marks. Take note of the marks and the punishments or the penalties. Okay, without the identity here. If you come and write the identity here too, anywhere that you didn't introduce any of the letters and you write the identity to, that will be -1. Take notes. Okay, so you need to know your stuff and how to use them. And I know I have given you all the tools. So you should know this. So don't write anything that I have not, okay, advised you, okay, or instructed you, okay, to do. All right, so now that will be it for question 1. Let's look at that of the words question 2. Okay, question 2, express the following in partial fractions. So this time around, we are going to go beyond the identities. So we are writing the partial fractions, not the identities. So we'll go beyond. After writing your identity, you go and find your letters that you introduce in your identities and come and substitute. Okay, and that will be it. So quickly, again, there is nothing salient for us to underline. Okay, so usually whenever you are given in partial fractions, you resolve or express. Okay, so okay, at this point you come and write question 2. Okay, solution first, solution to question 2a. Okay, you extract, so this is what you are given. And first point, proper or improper. And take note, the very first question here, this question is a past question, a recent past question, and is the current, the WASSCE 2024 for Nigeria. Okay, this question came. Okay, so I picked this question directly from it. Okay, so at this point, so listen, if you're able to do this, then it means you have arrived because you've solved a fresh past question. Okay, sort of. Okay, so now you extract B half. Okay, with this, you can see that you have a cubic polynomial in the denominator. And remember, this cubic polynomial has no constant for you to go and use your usual technique in factorizing. So remember, anytime you are given any expression that you are asked to factorize, okay, factorization lesson, you will be told that check whether you have a numerical factor apart from one that you can bring out, a variable factor that you can equally bring out, factor or factors, okay, before you think about using any of the special factorization techniques. So at that point, I know that this is factorable because obviously I can see the variable s in all of them, so it's factorable. So the first, apart from the numerical factor, apart from 1, I can't bring anything out. Okay, so immediately I realize that it's factorable, I'm going to take it out and factorize as my rough work. Okay, so it means I cannot write my identity straight away until I'm done with what? The factorization. So I can bring S out. Apart from 1, no other number can be brought out. So now I go to the variable. Yes, I can bring S out. If I bring S out, I'll be left with S squared plus 2S minus 8. But there's a quadratic expression which could be factorable. So minus 8, factor pair of minus 8 that you multiply, you get minus 8. Add, you get what? Positive 2. And that will give us, 4 and negative 2. And because this is quadratic with the leading coefficient being 1, remember I told you that we can factorize straight away without going to the grouping. Okay, so this will give you X in one bracket, S in another bracket. Look for your factor pair and come and attach. So that will help you complete your factorization. So at this point, you factorize all right, but your factorization is not complete. Once your factorization is not complete, you cannot go and write the identity. You have to completely factorize your expression. So now I import the factorized version of what I have here, and that's exactly what you can see there. So it's equal to import. Then now let's accept it purpose. So you can see the factorization again here is M1. Don't forget, to give your marks if you did that. If you did it, it was embedded here, which I advise you against. Then what do? You give your marks here. All right, time will deal with you for me later. If you don't go or heed, that advice. So at this point, I know I have 3 factors. Linear, none of them is factorable. So that will give me 3 fractions, 1 for each linear factor. So I can now write my identity. Still is identical to A over X, which is coming from this one. This will give me B over S plus 4, then C over what you have there. That will also give you M1. So don't forget the marks allocated. You can clearly see. So if I don't mention it, what is important to you, understanding what you have there. As for the marks, they are there, so you can attach them as and when I walk you through the steps. So now that I've written the partial fraction identity, I have to go and find the A, B, and C. And we said, what do we do? First step, write this side as a single fraction. So you take the LCM. And that will give us this. And since the denominators are the same, we now come and equate the numerators, So this implies that the numerator here should be equal to the numerator here. And that's what I have here. And that attracts M1 as well. So at this point, this is where you use either the cover up or the elimination method, or you use the method of comparing coefficients. But I've told you, when I have linear factors, I always want to go for the cover up or the elimination method rather than the method of comparing coefficient. So at this point, I use my first linear factor. I set it to be equal to 0, and solve. So S is equal to 0 is already solved. So it means I have to go for if S is equal to 0. Substitute, then simplify, and come and solve for my A. So this gives me the A. Again, I have X plus 4, X minus 2. I could have done S equal to minus 4 by using this factor. But I did S is equal to 2. I want to deal with the positive first. It doesn't really matter the order. So if S is equal to 2, so remember you set this one to 0 and you solve for your S. That will guide you as to the S that you are supposed to substitute. So again, S equal to 2, comma, you continue. Then you substitute, you come and simplify, and that gives you C to be equal to 5 on 12. Then if S is equal to negative 4, so that will be for the third one. You substitute, you simplify, and you end up getting B to be equal to this. So at this point, you know your A, you know your B, you know your C. So therefore, whatever that you were asked to resolve, into partial fraction or express as partial fractions will be equal to, now you can't use the identity because you are going to substitute the actual values, for A, B, and C. So the direct substitution is what you have here, M1. Then now you know you cannot conclude with what? Any expression containing even a single fraction where the fraction contains more than 2 division bars. So it means this can be simplified. So what do? You bring the 8 down, keep. So that gives us what you have there. You bring the 24 down to come and multiply this. So that will give you 41 over this. You bring the 12 down to multiply this, and that becomes your final answer. So take note. All right. And that will be it for 2A. Now let's go and look at that of what? Of the B. Okay, so the b, we have 1, okay, plus s squared over 1 plus x plus 2 all squared. So again, let's check whether what we have there is proper or improper. Degree numerator 2, that of the denominator will be 2. Okay, but so it means it is improper. Okay, so ordinarily I would have gone by the improper approach, write it as a sum of a polynomial and what, a rational function. But remember, I gave you a certain advice. Anytime you have a repeated factor and you realize that, okay, in the denominator, the repeated factor, okay, is only one, no other factor is attached to it, it is convenient and ideal for us to use the substitution method. So those of you who use the improper fraction approach, you will write more. It means you didn't heed advice and you waste our time. So at this point, going by the advice, we make a substitution for this, and even this question, we've solved it before. Okay, so let u be equal to your repeated factor, okay, s plus 2. Then you change from, okay, s to u. So it means I have to make s the subject here, which gives me s to be equal to u, okay, minus 2. Okay, then now I can write therefore whatever that I have here will be equal to 1 plus, okay, u minus 2 all squared. And in fact, the question that I gave you in class was s squared. The numerator was s squared plus 1. But you know that 1 plus s squared is the same as s squared plus 1. So you end up getting the same result. So in actual fact, it's the same question. Only that is the numerator expression that the terms were swapped by the same question. Okay, that was just by the way. So this will be equal to 1 plus, then you come and substitute for your x. Remember, you said x is equal to u minus 2. So u minus 2 in bracket, then squared, all over, you said s plus 2 is what? U. So it will be u squared. Now, you come and remove the bracket in the numerator, and to be 1 plus, you know how to expand a binomial by now. So we should know that if you have a, okay, minus b all squared, at this point, we should know that is equal to a squared minus 2ab plus b squared. Your a here is u, your b here is what? 2. So it will be u squared minus twice the product of this and this, which will give you 4u. Twice this is 2u times 2. So that will give you, sorry, the product of this and this will give you 2u times 2. That will give you 4u. Then plus 2 squared, which is 4, all over u squared. Okay, so now after expansion, you have like terms. So that gives us u squared minus 4u plus what? 5. I decided to write it in the standard form. Okay, so now all over. But you are dealing with partial fraction. This is a single fraction. So it will be each term over the denominator, or each term in the numerator of the denominator, okay, that you have there, and you simplify. So you end up getting your relation in terms of, or your expression here in terms of u. However, you want your answer in terms of x. So u has served its purpose. You know u, what is representing, and that is what? S plus 2. So you just come and substitute, and that will be it for the solution to that of the b. Quickly, let's go and look at what the c. I guess my point is well made. You can see the marks there as well, so I don't have to reiterate, okay, that. Okay, so c, again, this is also a known question. Okay, so let's see, we've been given 1 over what we have here. Okay, so remember I told you anytime you see s squared, okay, treat it as what? Don't treat it as a quadratic. Okay, treat it as a repeated factor. Okay, so that gives us what we have here. So this will give us 2 fractions. This linear will give us only 1 fraction. So in effect, we are going to get 3 fractions. So a linear repeated, linear x repeated. So a over x. So identical to, I can write the identity straight away. Okay, so then after that, I come and write my single fraction. Okay, the denominators are the same, so I equate the numerators. So this implies this. Okay, so here your factors are x. Okay, you know that, and 2x minus 1. So x is a linear factor which is repeated. So, but you have 2 linear factors and you have 3 letters. So this means that if you want to go the cover up or the elimination approach, you have to, at a point, settle on, okay, a convenient substitution if it becomes necessary. Okay, so now let's go and see. The first one, the first factor is x. So it means we have to go for x is equal to 0. Okay, so substitute, you end up, and simplify, you end up getting b to be equal to minus 1. Okay, then you go to, if x is equal to, so you equate this one to 0 and solve. Okay, I usually don't want to substitute fraction like I told you in class, but I decided to go that route so that those of you who would want to use the fraction to, you will know what to do. Okay, so just for flexibility's sake, that's the more reason why I'm introducing you to that. Ordinarily, I wouldn't have used that fraction. Maybe I would have gone for s is equal to 1. Okay, since I haven't used that, then maybe s is equal to any other value that I have, maybe 2. Okay, to get my letters, that's missing letters that I'm looking for. So I'm left with A and C to look for. So if S is equal to half, so I go and substitute. 1 will be equal to, so I substitute half, okay, wherever I see X here. And that's what I have here. And simplify, and that gives me, okay, 1 over is equal to 1 over 4C, or C over 4, which gives you cross multiply. So C will be equal to what? 4. Okay, so now you know you've used the factors, the linear factors directly involved, x and 2s minus 1, to do your direct substitution. You are left with 1. Okay, so this one you have to go for your value of what? Interest in terms of your substitution, your convenient value, like I always say, and that will be s is equal to 1. We've used 0. Other than that, we'd have gone for 0. So we move on to 1. We've not used 1. So if s is equal to 1, you substitute, simplify, you end up getting this. But you know the values, okay, of what? B and what? C. So you just come and substitute. Okay, and that's what I did here, and you use that to find your A. So A will be equal to this. If you add, you get positive 3 here, and you move it to this side. So it will be 1 minus 3, which will give you minus 2. So at this point, you know the values for A, B, and C. So let's go and check whether in our conclusion we can start with A. A is negative, we cannot start with. What about B? Okay, B is also negative, so you can't start with B. So what about C? C is what? Positive, so it means I have to start with this term. So that informed that decision. So if you substituted directly and you started with a negative, okay, then it means you will have one more step, rearrange. Because I've told you, avoid concluding with an expression that starts with a negative term if you have at least one positive term. Okay, so at that point, this is what you have here. Okay, so your direct substitution will give you this result. I guess my point is well made there as well. So now let's look at that of what? The D. Okay, D. All right, so D, again, let's check proper or improper. So let's see, degree of the numerator 2. That of the denominator, this factor here will give me a degree of 1. This factor will give me a degree of 2. So if I add, I'm going to get a degree of 3 to give me the general degree of the denominator. So I have 2 over 3, which is proper. So now, once it's proper, I go straight away to the denominator. This is a linear factor, which is not repeated. This is also linear factor, repeated. None of them is factorable. Okay, though 1 is repeated. So it means I can write the identity straight away. So it will be A over S plus 1. So this will give me one fraction. This will give me 2, you know. So B over X minus 1 plus C over X minus 1 squared. So at this point, take the single fraction, okay, then equate the numerators. Okay, so that is what you have here. And you should know, I've told you that the LCM will always be the same as the non-factorable factors that you were able to generate or that came directly from the question. And that's what you have here without thinking. You go through, okay, what you have here. X plus 1 will go into your LCM here, X minus 1 squared. So it will be times A plus, okay, this, okay, X minus 1 will go into your LCM here, S plus 1, S minus 1 times your B. That is what is there. Then your X minus 1 squared here will go into your LCM here, denominator here, S plus 1 times C. So at this point, denominators are the same, equate the numerators. Okay, so let's see. The factors are, the direct factors that we can use will be S plus 1, X minus 1. But, okay, 2 linear direct factors, but we have 3 unknown. So it means, as usual, at a point, you have to go for your convenience substitution. Okay, so now this one gives us X plus 1, X minus 1. Okay, so it means I will get s equal to minus 1 as one direct substitution, s equal to what? 1 as another direct substitution. But I want to start with the positive. So I did s equal to 1. Okay, substituted, simplified to get what? This as my c. Okay, then I went for the second one, x minus 1. Okay, substituted, simplified, and that gave me a is equal to what? 2. Okay, so you know the marks there. Now you are left with what? B. You found C and what? And A. So this point, you've exhausted your direct substitutions based on the factors, the direct factors. So you have to go for your convenience. So convenience, we start with s equal to 0. Have you done s equal to 0? No. So we go for that one. If s equal to 0, substitute, simplify. So if you substitute and simplify, you end up getting 1 is equal to a minus b plus c. Okay, but fortunately for us, we know the values for a and that of what? C. So you substitute. A is 2, b is minus what? 4. And simple and solve for b. So b will come here. Here will give you 2 minus 4, which is minus 2. Then this will come here. So minus 2 minus 1. So b will be equal to minus 3. Then at this point, once you know the values, you go and substitute and draw your conclusion at that point. So therefore, okay, whatever that you were asked to express in partial fraction will be equal to, okay, let's check whether we can start with the A. A is what? Positive, so we can start with the A. So that's informed as 2 over. Then B, okay, we remember there's a B gave us what? Negative 3, so it will be minus 3 over that. Then C gave us what? Negative 4, so minus 4 over what we have there. We are done with the solution to that of what? The D. Okay, so quickly, okay, now let's look at this question. E was a direct question, and I think that was even the last assignment that was given in the last lesson on, okay, partial fractions. Okay, so this is it. Okay, so with this one, I won't waste time. Okay, I will quickly or briefly walk you through because you have the solution on the platform. Or if you like, you can still go to my YouTube channel and watch, okay, the solution to this particular, okay, question there. All right, so now what do we have? Given this, proper or improper, degree of the numerator is 3, degree of the denominator is what? 2. Okay, however, you don't have a repeated factor where there is only one repeated factor in the denominator for me to use the substitution, okay, method. So in this case, hard way, the only way, we have to go the improper rational function resolution, okay, way. So now what do? We know that we need to write this as what? A sum of a polynomial plus a proper rational function. So we need to expand the denominator, then go and carry out our long division, so that we'll get the polynomial, which will be our quotient, plus your rational function, which will be your remainder over the divisor. So you go through the long division, okay, here. So you do this, you know, your divisor comes here, your dividend will be here. Your divisor is not necessary to write it out completely. What is important is make sure it is in the standard form. However, your dividend, okay, for convenience sake, write it in the standard form and also in its complete form. So you can see that the s squared term is missing, so you introduce that. Okay, it's in the standard form, but not in the complete form. Okay, so you go through, you know, the long division, and that gives you this as your quotient, this as your remainder. So it means what I have here will be equal to the quotient, and because it's a binomial, don't forget to put it in brackets, plus your remainder, and your remainder is this, over the divisor, and the divisor, go for the factorized version of the divisor, because we know we are going to take this one and resolve. And when you are resolving, if you take this one, we need to go and factorize. So that's, okay, if you do this, then the factorization has been taken care of. So you take this one, then go and write the partial fraction identity. Okay, so you know, linear, linear. So that will give us 2 fractions. You can write the identity straight away. So this will give you a over s plus b over 2s plus 1. Then what do? We know, take the LCM. after taking the LCM, the denominators are the same. So what do? You equate the numerator. So the numerator here equated to the numerator here. And remember what I said when I was walking you through this one. I wanted to, so this one is the situation that I went for. Okay, this one will give you your, at the normal sequence, I should have gone for s equal to 0, then s equal to minus 1 over 2 as your direct substitution based on the linear direct factors. Okay, so if you do that, then you will get your two. One will give you the value for A, the other will give you the value for B directly. But I decided to go for, so the first one, s equal to 0, will give us the value for A. So it means the second one, s equal to minus 1 over 2. If you go for that fraction, minus 1 over 2 for x, substitute, you end up getting the B directly. But if you look at what I said in our lesson, I said I wanted to, okay, avoid, what do you call it, a fraction. So I use my expression here, okay, to what I have here. Okay, to avoid a fraction, because if I substitute 4 here, this will cancel, the fraction will go. Okay, nonetheless, you can use s equal to minus 1 over 2, as I said earlier. Okay, so I went for s equal to 4, substituted, simplified. Okay, I substituted, that gave me, and simplified, that gave me 55 is equal to 9a plus 4b. But we know a, that was 14. Substitutes, then you simplify and solve for b. Then at this point, you come and substitute. Okay, and draw in your conclusion as well. So that will be it for solution to the entire question 2. So we are left with that of what? The last question, question 3. Okay, so this is it for question 3. Okay, so question 3, this one was also a known question. Okay, only that I think in the original question it was A and B. And you were asked to write it, find the value of A, comma B. Okay, they were different letters. I just changed the letters here. So this one too, you have the solution to. So if you're not able to do it, then it means you didn't do thorough revision and you need to set up. All right, you shouldn't be happy at all, especially questions that you've seen, okay, before. Okay, so you should know the questions and the question must also know you. All right, so at this point, I know, what do I do? We said you come and write. So the identity has been given, okay, directly, because if you see the denominator of this one is the same as this factor, denominator of the second one the same as, so it means directly this has been given in terms of what? The partial fraction identity. So you move on to resolve. So take the LCM, which is what you have there, and now you come and equate the numerators. Okay, the linear factors are s plus 3, x plus 6. So you go for x minus 3, then the other one will be x minus 6. So do that and simplify. That will give you s minus 3 simplified, substituted and simplified will give you, simplified will give you p is equal to minus 2. If s is equal to negative 6, substituted, simplified will give you q is equal to 4. So now you come and draw your conclusion. Therefore, what you were asked to find, so you leave your answer as a point. So it will be in brackets, okay, as a point, PQ is equal to minus 2, 4. Take notes, okay, that the P is the one that should start, okay, and the Q. In fact, I'd wanted to change it to, okay, it was it QP? Yes, so in fact, that is what I wanted the question to be. So originally it was PQ. Now it is QP. So please take note. So let me quickly do the editing here. So that was the intent. So it's QP. So you have to be very, very careful as well. QP. Okay, so QP, take note. So it means this should come here and this should equally move to the side. Take note. Okay, so in actual fact, this is what you should have. Okay, there. You should be there for, okay, it is what? QP. Okay, will be equal to, what is your Q? Q is what? 4. And what is your P? Minus 2. So take note. So it should be exactly this before you can get this mark here. So the first one was wrong. So take note. You have to be very particular. So I thought I didn't put it that way, not knowing I did. Okay, I equally didn't pay attention to details. So take notes. Okay, check whether it reflects exactly what you have there before you move on. So now the B, okay, which was a little technical but not difficult. It's just similar to what we did here. Okay, only that here we're asked to find the value of u. Okay, so what do we do? The identity has been written. However, you have to be very careful. Okay, so it means here, okay, the identity would have been a letter over, which is u over s plus what, 4, plus what, okay, another letter, maybe v over x minus 3. But if you look at the way the resolution has been done, because this value has been given, the second, okay, letter for this second factor, okay, has been given. And if you look at it carefully, because here there is 7, it means that when you solved, you had 9 over 7. So you can take it back, okay, so that you will get directly the factors here. Okay, or you can take this, okay, that wasn't the route that I went. You can take this, resolve, okay, and now come and compare and use, okay, your compare to get the value of your u. But I didn't do that. So I did what I have here, the identity has been written, is equal to u over this plus. Now I took this one up, so that gave me 9 over 7. So now if I take the LCM, they will be the same. If you didn't take this one up and you took the LCM, you realize that the LCM for this one and that one will not be the same, because the second one will give you 7 into what you have there. So that means you cannot equate the numerators at a point and you'll be stuck. So at this point, I brought this one up and took the LCM, and the LCM, once I take the LCM, I know this will go into this how many times? It will be x minus 3 times by u. Then this will go into this how many times? S plus 4 times, and times this. That will give me what I have here. So at this point, I know obviously my denominators are the same, so I can come and equate the numerators. Okay, and substitute whatever that you want to substitute. So here, my concentration, I'm looking for u. Okay, so once I'm looking for u, then I have to cover this. Because if I come and cover this, the u will go. Okay, so, and that will give you indirectly, or someone even can substitute any value for x. Okay, any value for s, and now, okay, you go and deal with algebra in terms of only u and some constants. This is allowed. But I decided to cover this. If I cover this and deal with this one, will go, my algebra will be very easy. Okay, so in that case, if s is equal to minus 4, okay, I substituted, simplified, and that ended up giving me u to be equal to minus 23 on 7. But remember, this u here is an improper fraction. We avoid concluding with an improper fraction. So you take it to its corresponding Mezz numbers. So if your answer is not in the Mezz number, this is where you end. Your conclusion would be A0 if you concluded with an improper fraction. You've lost marks that you were not supposed to lose, because I've been telling you times with that number. Okay, so in all, the total marks should be 98. Okay, then plus 2 bonus marks, making the grand total to be what? 100 marks. Okay, so now this is how I am going to distribute, okay, my bonus mark of 2. So the bonus mark, if you had, okay, 90 to 95, between 90 and 95, okay, let me even make it 94. Okay, it will be plus 1. You get only one of the bonus marks. However, if you scored 95, okay, to 98, you will get plus 2. Take note. So it means if you scored 94, let me make it 94.5. So if you scored 90 to 94.5, okay, or 94.5, you will still get plus 1. You don't round it, you know. Okay, then 95, okay, going up to 98, you get your plus 2, making it a total of what? Okay, 100 marks. So I guess my point is well made. Just as I said, after watching the video, if you have any concerns, please, okay, send me a message via the comment section, and I will address that. So you can, okay, subscribe to my YouTube channel, okay, like and share this video as well. So at this point, thank you very much. Okay, God bless us. Thanks for your attention and for your time.